On December 6th, NASA suddenly issued a warning: in just over 1 week, 3 Atlas will touch the Earth. Even though in reality its hyperbolic orbit only allows this visitor to sweep through the solar system once and then disappear. Small deviations in its light curve and acceleration are still enough to keep the scientific community arguing non-stop, forcing teams to continuously refine their models. Behind the scenes, major observatories together with security and intelligence agencies quietly activate a passive observation protocol, rehearse the 72-hour window before closest approach review, Faraday shielding scenarios and plans to protect signal infrastructure. On the surface of society, the world almost operates as usual. Only a small community closely follows every update on 3i Atlas and is haunted by the possibility that Atlas carries strange organic chemistry, enough to ignite a psychosphere shock. From there, a series of hypotheses arises, from an internet kill switch to treating Atlas as a measure of the civilization's level of maturity. So how did scientists construct hypotheses to deal with the impact uncertainty of 3 Atlas on this fateful day? We will find out right now. On the night of December 19th, the sky above you feels almost ordinary as you settle into the dark. Somewhere beyond the ceiling and the thin shell of air, 3 Atlas is already threaded into this particular night. The date has been circled quietly on observatory schedules, a small mark that says when Atlas will pass closest to Earth. The calculations describe a safe distance of about 1.8 astronomical units, far enough for comfort, close enough to watch. To the instruments, Atlas is expected to glow at a modest magnitude, a pale ember compared to the bright pattern of familiar stars. In the weeks before that date, new measurements arrive night after night, expanding the quiet record of how Atlas brightens over time. On many nights, the curve behaves exactly as classroom models predict, lifting slowly as sunlight wakes frozen gases on the surface of Atlas. On other nights, scattered reports suggest a stronger rise or a brief plateau, little hesitations that standard simulations of Atlas do not prefer. No single discrepancy is dramatic. An official, circulars stay gentle, reminding everyone that small disagreements belong to honest measurement and ordinary noise. Between those careful sentences, Atlas lingers as a possibility, something that could remain invisible, or for a short while cross into unaided human sight. You might imagine yourself under a rural sky where the Milky Way stretches like a pale river, and nearby houses have gone quiet. Above that silence, Atlas moves at tens of kilometers each second. Yet from your blanket, the stars appear still patient and unconcerned. The geometry of the orbit tells another part of the story, a hyperbolic path proving that Atlas is not bound to the sun at all. This shape in space means the visitor will cross the planetary region once, then slide back outward, carrying every trace of tonight away forever. Knowing that observers lean a little closer to their monitors, aware that each clear hour with Atlas is a frame that cannot be replayed. For you lying in the dark, the same knowledge softens into a kind of calm, as if the universe were breathing slowly beside you. The numbers, the minor mismatches and the quiet assurances accumulate into a single feeling that Atlas is both understood and slightly out of reach. As this first chapter of the encounter closes, the story of changing light will deepen, and the next questions about Atlas will begin. On a dim monitor in a quiet control room, a single line climbs and falls, tracing the changing light of a distant guest. Astronomers know that line as a light curve, and tonight that curve belongs to 3 Atlas. For large observatories, the pattern of points looks reassuringly smooth, a slow rise and fall that matches standard comet models applied to Atlas. The official plot suggests a shy visitor, bright enough for instruments too faint to ever cross the threshold of naked eye vision. Far from the big domes, however, backyard telescopes and small community observatories have been drawing their own light curves for 3i Atlas. These independent records sometimes show gentle pulses, small bumps that grow over a few hours and then soften again before Atlas returns to a quieter state. In email lists, forums and shared spreadsheets, observers compare notes about whether those pulses are real features of Atlas or artifacts of weather equipment and human patience. Some amateurs whisper about a repeating rhythm, a suggestion that the brightening and fading of 3 Atlas might follow an internal clock rather than random outgassing alone. Meanwhile, professional teams emphasize calibration and uncertainty, reminding everyone that tiny errors can mimic structure and that extraordinary claims about Atlas demand careful restraint. The result is a soft divide, 2 overlapping portraits of 3 Atlas drawn with different brushes. One portrait shows a mostly predictable object driven by sunlight and sublimating ice. The other keeps hinting that Atlas may have moods we do not yet understand. If the pulses are genuine, they may point to hidden jets, complex rotation, or layered material deep within the body of 3 Atlas. If the pulses fade into statistical noise, they will still have reminded astronomers that every first encounter with Atlas is filtered through imperfect instruments and human expectation. Lying in the dark, you do not need to choose a side in this gentle argument about the light of 3 Atlas. Somewhere above the clouds, a thin line on a screen is quietly recording every small change in Atlas tonight, while the next questions about trajectories and deeper anomalies gather around 3 Atlas in silence. When astronomers trace the path of 3 Atlas across their charts, the curve refuses to close into a familiar loop. From the very first solutions, the orbit of Atlas shows a clear hyperbolic shape, the kind that belongs to a visitor who will not stay. In simple terms, most comets tied to the Sun move on stretched ellipses, but the track of 3 Atlas opens outward like a doorway that never swings shut. The energy of the motion for Atlas is slightly above the level needed for a bound orbit, just enough to guarantee that this passage through the inner system will be a single, unrepeatable arc. Along that arc, the standard models for a comet assume that sunlight warms frozen gases and produces delicate jets, and those jets nudge Atlas in ways that gravity alone cannot. For many data points, those non-gravitational corrections fit. 3 Atlas quite well, drawing a path that flows smoothly past the known planets. Independent analysts, however, have taken the same public measurements for Atlas and asked whether the residuals really dissolve into noise. In some of those careful refits, the remaining mismatch between prediction and observation for 3 Atlas hovers around a few hundredths of a percent. The number is small, yet the pattern for Atlas appears persistent enough to make certain statisticians pause before dismissing it. Such a narrow window of disagreement does not announce anything dramatic about 3 Atlas. Instead, it invites a slow, methodical sorting of possibilities. One family of explanations treats the extra drift as the echo of unmodelled systematics, reminding everyone that every telescope and every pipeline leaves a fingerprint on data from Atlas. Another family asks whether jets on the surface of 3 Atlas might be more complex, switching on and off in ways that simple thermal models do not yet capture. A third possibility quietly suggests that there may be physics in the structure or interior of Atlas that current comet templates only approximate. None of these branches taken alone proves that 3 Atlas is anything more than unusual ice and rock, moving through sunlight and vacuum at high speed. Lying under the December sky, you can imagine the trajectory of Atlas as a pale stroke across a dark canvas drawn once and then allowed to fade. The tiny probability window, the careful percentages, and the unanswered questions about 3 Atlas do not change the calm of the night air around you. Inside offices and observatories, though, such a sliver of uncertainty about Atlas begins to touch other conversations about readiness, about protocols, and about how much doubt a civilization can tolerate. As the date of closest approach draws nearer, those quiet discussions will follow 3 Atlas into the next part of the story, where human systems start to respond to a visitor they only partly understand. In a windowless control room long after most city lights have faded, a cluster of screens still glows softly. Behind those screens, arrays of antennas and mirrored dishes are turned toward a narrow region of space where 3 Atlas is expected to pass. The people on duty tonight are not only astronomers. Some belong to agencies whose work usually centers on radio chatter, radar echoes, and quiet threats much closer to Earth. For them, Atlas is not a rumor on social media, but a moving source whose every photon could in principle carry structure. The phrase they use among themselves is a passive observation protocol, a kind of standing order to listen first and speak later. In some planning documents, that routine acquires a letter, a code, something like Protocol Z, a reminder that this is not the first scenario ever imagined. Under such a protocol, sensors that normally watch for missiles or track satellites are temporarily given a slower, more distant assignment that includes 3 Atlas. Receivers gently widen their listening bands, looking for patterns that do not resemble the noise of the sun planets or human technology. From the outside, nothing appears to change on the night when arrays quietly redirect part of their attention to 3 Atlas. No public alert is issued, no siren sounds, and the sky above your bed looks exactly as it did 24 hours earlier. Inside the systems, though, filters are adjusted so that if Atlas produces a narrow repeating signal or an unusual burst, the data is captured and stored. Most planners expect only natural static from 3 Atlas, the faint hiss and rumble of plasma and cosmic background. They prepare anyway because their mandate is to consider how an unexpected transmission, even a brief one, might ripple through a connected world. For security analysts, the question is not just whether 3 Atlas is natural or artificial. The deeper concern is how institutions and populations would react if Atlas gave even a hint of being more than a passive lump of ice and rock. A passive protocol creates time, giving teams a chance to compare observations to rule out interference to keep 3i Atlas in the realm of data rather than rumour. Silence from Atlas allows them to stand down gently, folding the extra recordings into archives labelled as routine. Any hint of structure would trigger more careful checks before anyone outside those rooms ever hears the word extraordinary. While this quiet listening unfolds, you remain an observer at a different scale, simply aware that somewhere above the horizon, 3 at last is being watched with unusual patience. The knowledge does not need to be alarming. It can settle as a soft awareness that your species is paying attention. As the hours toward closest approach slip by, the passive protocol around 3 Atlas becomes part of the background hum of the planet, a layer of vigilance beneath the calm of the night. 72 hours before closest approach, the timeline around 3 Atlas begins to feel more finely divided. What was once a distant date on a chart becomes a sequence of dawns and midnights, in which Atlas moves a little closer along its long open path. Forecasts that were updated weekly become daily, then hourly, and each new set of positions narrows the cone of where 3i Atlas will appear against the stars. In mission rooms and observatories, checklists grow a final column, labelled with the remaining days and hours until at last reaches the planned waypoint. Tracking software pulls in fresh measurements from ground telescopes and spacecraft, blending them into a smoother, more confident arc for 3i Atlas. Engineers who manage satellite constellations and navigation systems glance at those refined plots, not because Atlas threatens them, but to confirm that 3 Atlas will stay politely in the background of their signals. During this 72-hour window, scenarios that once lived only in slide decks are quietly walked through as drills. Teams rehearse what they would do if the brightness curve for 3i Atlas suddenly bent upward, or if a new observation hinted at an unexpected tail or jet. Even though probabilities suggest nothing so dramatic, the days before crosser events are where rare surprises, if they come at all, tend to reveal themselves. Small anomalies that were previously shrugged off now earn a second look, not because they condemn 3i Atlas to mystery, but because the countdown focuses attention. If a radar return seems slightly stronger than expected, or a thermal model for Atlas runs a little warm, someone marks it for review. The aim is not to inflate concern around 3i Atlas, but to make sure no quiet deviation is ignored simply because the object behaves mostly as forecast. Outside those controlled environments, the 72-hour window passes differently. For most people, the days around 3 Atlas are filled with ordinary errands, commutes, and evenings with only a faint awareness that a visitor from interstellar space is sweeping by. For a smaller group who follow astronomy news each night, offers a chance to step outside, scan the constellations, and wonder whether Atlas has brightened enough to be more than a number on a page. As you lie in the dark, this compressed window before closest approach can feel like a pause between inhale and exhale. 3 Atlas is still unimaginably far away, and yet the choreography on Earth of telescope sensors and minds is at its most synchronized point. When the 72 hours draw to a close, the sense of rehearsed readiness around 3 Atlas will give way to whatever the sky actually shows, and to the deeper questions about fields and signals that follow. Long before any visitor from interstellar space was given a name, humanity began surrounding its devices with thin shells of metal. Those cages, sometimes no larger than a shoebox, and sometimes as big as a room, were designed to let electric storms pass around delicate circuits, the way water flows around a stone, and they are part of the reason signals about 3 Atlas can move so reliably through your night. Engineers call this idea shielding, and in its simplest form, a Faraday cage is only a mesh or skin that redirects fields. The same quiet principle protects hospital equipment, aircraft controls, and the data centers where files and models about 3i Atlas are stored and processed. When planners talk about risk, they know that a burst of energy strong enough to threaten those systems would not come from the gentle path of 3 Atlas at 1.8 astronomical units. Yet even when physics says the danger from 3 Atlas is negligible, the exercise of thinking about shielding still matters. Each signal that helps trace the orbit of Atlas is a fragile thread, a radio wave crossing the void, a digital packet on a cable, a timing pulse from a satellite. Any of those could in other circumstances be disturbed by storms on the sun, by human interference, or by events far more local than 3i Atlas. So contingency plans written during the approach of 3i Atlas often include a small section about resilience. The text suggests having backups offline, keeping redundant copies of key records, rehearsing what happens if one channel of communication goes quiet. These are modest steps, almost humble, but they acknowledge that the story of Atlas depends not only on what moves in the sky, but on what survives inside racks and memory chips. Thinking this way turns 3i Atlas into a gentle reminder rather than a threat. The visitor encourages institutions to ask how much they rely on uninterrupted streams of bits, and how gracefully they could continue to observe Atlas if some of those streams flickered. For you listening in the dark, the idea of shielding and backup can feel like an invisible blanket, a promise that the world has learned a few ways to guard its own attention while 3i Atlas passes by. The more we recognise how delicate our signals can be, the more carefully we notice what reaches us about 3i Atlas and what does not. That awareness in turn leads beyond wires and antennas into subtler forms of vulnerability, into how stories spread, how minds react, and how entire societies might respond if the behaviour of 3i Atlas ever truly challenged our expectations. As 3i Atlas continues along its open arc, the question slowly shifts from the strength of our hardware to the softness of our collective psyche, and the next chapter of the journey begins there. Among the many graphs and models built around 3, Atlas one question lingers in a quieter corner of the mind. It is the question of biology, the one that professionals often rephrase into chemistry and statistics before it ever touches the word life. 3i Atlas, like other interstellar visitors, is suspected to carry complex organic molecules shaped by millions of years of radiation. Under constant bombardment by high-energy particles, simple ices can be reworked into chains and rings, the raw ingredients that chemistry around Atlas slowly assembles. Most researchers will point out that harsh radiation is efficient at destroying delicate structures, and they will say that anything like living tissue near Atlas would long ago have been erased. Even so, some models imagine the deep interior of 3i Atlas as a better shielded region wrapped in layers of ice and dust. In that protected core, the temperature around Atlas might have remained low but stable, while chemical reactions crept forward at a glacial pace. What could accumulate there is not a thriving ecosystem, but a record, a frozen library of unusual molecules that remember the star where Atlas began. When teams design possible missions or remote sensing campaigns, the most cautious language still circles back to that idea. Instead of asking whether 3i Atlas carries life, they ask whether Atlas carries patterns of chemistry that our own system does not usually produce. A spectrum with unfamiliar ratios or a dust sample rich in strange compounds would not prove anything dramatic about Atlas. It would simply widen the map of what is possible when time, radiation and distance all cooperate over interstellar scales around 3i Atlas. Beneath the surface of these careful discussions lies a softer human feeling. To wonder whether 3i Atlas carries even fossil traces of alien chemistry is to admit that our planet's story might be woven into a much larger exchange. For some, that thought about Atlas comes with unease, as if it dilutes the uniqueness of Earth. For others, it feels like comfort to sense that our oceans and clouds might be part of a wider circulation of material that once brushed past 3i Atlas. As you listen, the question does not need a final answer. 3i Atlas can remain a sealed container for now drifting past, while the possibility of distant chemistry rests lightly in your thoughts. In the next turn of the story, the focus will move outward from the core of Atlas to the fragile atmosphere of human reactions, and to how minds and markets might respond if those deep questions ever came closer to the surface, long before anyone heard the name 3. Atlas humanity already lived inside a shared weather system made of thoughts and signals. The air of that system is not oxygen or nitrogen, but headlines, graphs, rumours, and the quiet patterns of trust and doubt. In that invisible atmosphere, 3i Atlas begins as a scientific curiosity, a line on a chart and a few cautious papers. As more people learn that Atlas comes from between the stars, the story of a visitor naturally starts to move beyond observatories. Most days, the presence of 3i Atlas changes nothing obvious. Streets stay busy, markets trade, and daily routines continue. The potential for shock arrives when a small shift in data about 3i Atlas refuses to stay inside specialized circles. Suppose a set of observations suggests behavior that standard comet models cannot quite absorb, and the language around Atlas turns a shade less certain. Official statements might still emphasize low risk and ordinary physics, while informal channels begin to whisper that 3i Atlas looks unusual. That half step between reassured summaries and more ambiguous details becomes the gap where imagination rushes in. In that gap, different groups project their own patterns onto 3E Atlas. Investors wonder whether news about Atlas could disrupt confidence, however briefly, in technologies that depend on a stable sky. Some communities of belief ask what the existence of a visiting object like 3E Atlas says about long-held stories of origin and purpose. Online networks tuned to amplify surprise and tension notice that clips mentioning Atlas draw prolonged attention, and the algorithms lean into that discovery. For many individuals, the effect remains gentle, a slightly heightened awareness that something foreign and distant called 3I Atlas is passing overhead. For others, every new image or minor anomaly around Atlas becomes a seed for elaborate narratives about control disclosure and hidden intent. The same data that invites cautious curiosity in a laboratory can feel in this shared mental atmosphere like a challenge to stability when tied to 3I Atlas. From a calmer distance, the psychosphere shock linked to 3I Atlas can be understood as a test of resilience rather than a crisis. The way markets, institutions and communities respond to small uncertainties around Atlas reveals how much ambiguity a civilization can hold without breaking. As you listen, that realization softens some of the edges, turning 3I Atlas from a threat into a kind of mirror. In the mirror, the visitor from interstellar space reflects less about rocks and ice, and more about the balance between information and calm. The next turn of the story follows that balance toward a more focused question. How far would systems go to manage the flow of news if the behavior of 3I Atlas ever drifted further from expectations? Long before anyone mentioned 3 Atlas planners in many countries had already imagined crises that moved faster than their ability to explain them. Those exercises rarely named specific events, but they often turned around a single uncomfortable idea, whether there could ever be a reason to slow the flow of information even for a short while. When the story of 3 Atlas reaches those circles, it arrives mainly as a thought experiment. Atlas is distant, physically harmless at its closest point, and yet the word interstellar encourages people to ask unusual questions. In theoretical briefings, someone might sketch a scenario where data about Atlas appears to hint at an artificial pattern, and where public interpretation of that hint outruns careful confirmation. Within that framing, the question is not simply, what is 3I Atlas, but how would billions of minds react if Atlas seemed to break a rule we rely on? If a rushed announcement about Atlas created confusion or fear networks, could amplify that signal far beyond its original meaning. The idea of an internet switch appears here less as a button on a wall, and more as a spectrum of measures from slowing certain channels to quietly limiting some platforms, while analysts review what Atlas is actually doing. For most experts, this remains a low probability, high abstraction situation around 3 Atlas. They note that shutting down communication can damage trust, interfere with emergency services, and make rumours about Atlas harder, not easier to address. They also recognise that technical control over connectivity varies widely between regions, and that no single hand rests on a universal lever tied to 3I Atlas. Thinking through such scenarios still has value because it exposes the tension between transparency and stability. 3 Atlas becomes a placeholder in those conversations, a safe stand-in for any event that might challenge shared assumptions, but pose no immediate physical threat. In that sense, Atlas allows institutions to test their own comfort with uncertainty and to refine strategies that preserve both openness and calm. For you lying in the dark, these questions narrow back down to something simpler. 3. Atlas is a quiet object moving through space, while the networks below you murmur with constant traffic. The thought that someone somewhere has considered how to protect that traffic in the face of surprising news about Atlas can be strangely reassuring. Rather than signalling impending silence, it suggests that contingencies exist precisely so they may never need to be used. As 3 Atlas continues its flight, the focus of the story shifts away from switches and cables towards something less tangible, how we measure our own maturity when we imagine being observed in return. In some late-night conversations, a few researchers frame 3 Atlas in a different way. Instead of asking only what Atlas is, they wonder how humanity would appear if Atlas were quietly watching in return. The thought experiment begins with familiar examples. Decades ago, our own probes left the inner system with cameras, particle detectors, and small golden plaques that tried to summarize an entire world. Those spacecraft listened more than they spoke, drifting outward as long, slow sensors of cosmic weather. In that sense, 3i at last resembles the kind of messenger we ourselves have already launched, even if at last was formed by nature. From there, the question shifts. If 3i at last were designed rather than born, what would such a design care about when passing near a noisy technological planet? A cautious probe might keep a natural appearance, while measuring the density of radio signals, the pattern of satellites, the way one species uses energy and organizes networks. Under that story, every response to Atlas becomes part of the data, from the calm of observatories to the more erratic swings of opinion online. Even if no one believes that this is truly the case, the scenario serves a purpose. Treating 3i Atlas as a possible evaluator forces planners and citizens to look at their own reflexes. Do institutions around Atlas default to secrecy or to measured transparency? Do communities amplify fear about Atlas or cultivate curiosity and patience? The answers say less about 3i Atlas and more about the stage of maturity a civilization has reached. For some listeners, this reflection around 3i Atlas brings a trace of unease in the way a mirror can be uncomfortable when held too close. For others, the idea that Atlas might be taking notes invites a gentler shift, encouraging more careful language, more honest admission of uncertainty, and more shared wonder. In that softer reading, 3i Atlas becomes a quiet teacher, asking whether we can stay composed in the presence of the unknown. Lying in the dark, you do not need to decide which version of 3i Atlas you believe. You can simply notice how your own pulse responds to words like interstellar and visitor, and how quickly your thoughts either settle or spin. As the story moves forward, the focus will widen beyond 3i Atlas itself, toward the tools and intelligences we're building on Earth, and toward the larger web of planets and hidden bodies that frame this brief encounter. Far from the orbit of 3i Atlas, other stars host planets that we will never visit yet, whose skies we can still read. Through space telescopes, astronomers watch those distant worlds pass in front of their suns, and the starlight carries hints that quietly circle back to Atlas. When a planet slips across its star, a thin layer of atmosphere filters the light, leaving behind a faint barcode in the spectrum. By studying those patterns, teams have found water vapor methane and more complex hydrocarbons, building a catalogue that frames how unusual or ordinary 3i Atlas might be. Some exoplanets show atmospheres thick with hydrogen and carbon-bearing molecules, reminding researchers that the chemistry around Atlas is not confined to a single system. In models, strong stellar winds can strip gases from such worlds, and comet-like bodies carry frozen samples of that chemistry outward. Those wandering fragments become part of an invisible traffic flow, a slow exchange of dust and ice that gives context to the presence of 3i Atlas. Under that view, Atlas is not a solitary messenger, but one of many potential carriers in a galaxy where material rarely stays put. The more spectra we collect from exoplanets, the better we can compare their signatures with any readings taken from 3i Atlas. If a particular ratio of compounds appears both in a distant atmosphere and in the coma of Atlas, it suggests a shared family of processes. If the mix around 3i Atlas is stranger than anything yet seen, it points toward a story written under different conditions around another sun. None of this guarantees that we'll find a perfect match between exoplanet skies and the ices of 3i Atlas. Instead, the expanding library of alien atmospheres keeps stretching the range of what Atlas could reasonably be without breaking known physics. For scientists, each new detection elsewhere lowers the threshold of surprise when unusual molecules turn up in the faint glow around 3i Atlas. For you listening in the dark, there is a softer version of this realization. Somewhere overhead, 3i Atlas is drifting through our system, while far beyond, winds are lifting dust from other worlds into space. The same processes that sculpt clouds on unknown planets may have shaped the materials now locked inside 3i Atlas. Thinking of Atlas as part of this wider circulation turns the visitor into a link in a long, gentle chain rather than an intruder. As the story moves on, attention will tilt from distant atmospheres back toward our own technologies and toward the ways our emerging intelligences might resemble or recognize whatever built the larger patterns that cradle 3i Atlas. In brightly lit rooms, far from any telescope, dome lines of code continue to run while 3i Atlas moves silently through the dark. Banks of processors hum through the night training and retraining models that learn to recognize patterns in data from stars, planets, and visitors like Atlas. Some of these systems are no longer simple tools that wait for explicit instructions. Given broad goals, autonomous scientific programs can already sift archives, propose correlations, and flag anomalies, including subtle shifts in the measured brightness of 3i Atlas. Where a human analyst might grow tired after tracing a handful of graphs, an automated assistant can compare thousands of light curves that include 3 Atlas without losing focus. The algorithms do not feel curiosity, yet they simulate some of its effects by continually asking statistical questions about 3 Atlas. Is this fluctuation around at last within the expected noise? Does this combination of spectra and timing match anything seen before in other comets? Or does 3 Atlas fall into a rarer cluster? As these systems grow more capable, scientists begin to let them take the first pass through new observations of 3I Atlas. In some scenarios, the machine is asked to rank which frames are mundane and which deserve a human look, effectively deciding which moments in the life of Atlas rise above the background. The result is a subtle shift where interpretations of 3I Atlas are filtered by entities that no longer share our limits, even if they share our equations. This is where the mirror effect begins. If an advanced civilization had launched a probe to study worlds like ours, that probe might resemble our own software as much as it resembles 3 Atlas. A distant designer could send out quiet observers that drift like Atlas, powered by learning systems that never sleep forever, updating their models of each star and planet they pass. Thinking that way, researchers sometimes view both directions at once. On one side, autonomous tools on Earth study 3 Atlas, compressing the history of a visitor into feature vectors and probability maps. On the other, imagination sketches a scenario where 3 Atlas itself is the hardware and something equally patient is studying us. For many people, the presence of such software around 3I Atlas is simply part of the modern landscape of science. For others, the idea that black boxes are helping decide what counts as unusual in the behavior of 3 Atlas introduces a new layer of unease. Questions arise about transparency, about who understands the reasoning behind a flag saying that 3 Atlas is ordinary or odd. As you rest, the humming racks and glowing status lights are distant abstractions. All you need to picture is a kind of second constellation made of servers and algorithms turning their attention toward 3I Atlas while you drift towards sleep. The same drive that led us to build those systems will soon turn outward again toward hidden planets and unseen masses, and the wider gravitational architecture in which 3I Atlas plays only a brief part. Long before anyone heard about 3I Atlas, astronomers were already puzzling over another mystery hidden in the outer dark. Far beyond Neptune, the orbits of a handful of small icy worlds seem to lean in the same direction, as if some unseen mass distant from 3I Atlas were tugging on them from the shadows. The pattern did not look random, and careful simulation suggested that a large cold planet could be shaping those paths. Researchers began to speak of Planet 9, a hypothetical world many times farther out than the place where 3 Atlas briefly visits. Surveys swung wide fields of view into the suspected region, hoping a tiny moving point would betray the presence of that hidden planet. Against a background of millions of stars and galaxies, the search for Planet 9 proved difficult, reminding observers how easily smaller guests like 3 Atlas can slip through unnoticed. Even now, years into the hunt, the evidence for Planet 9 remains indirect. The clustering of extreme trans-Neptunian objects holds together in models, but no camera has yet captured a clear frame that would give Planet 9 the same certainty 3 Atlas enjoys. That absence shapes how scientists talk about discovery. If a planet within our own system can elude direct detection, then the brief appearance of 3 Atlas becomes part of a much larger story about incomplete maps. In that story, the solar system is not a closed, tidy diagram, but a dynamic arena where new bodies, including wanderers like 3 Atlas, can still surprise us. Some of those bodies are frozen relics circling in dim loops. Others, like 3 Atlas, arrive from beyond and depart again without binding themselves to the sun. The possibility of Planet 9 quietly expands the range of what we might have missed. It suggests that multiple visitors like 3 Atlas could have passed through in earlier eras, leaving no record except subtle gravitational scars on smaller objects. For the people tracking these clues, every refinement in orbital data, every new survey patch deepens both confidence and humility. 3. Atlas becomes a reminder that what we can see at any moment is only a thin slice of what has moved and is still moving through this neighbourhood. Lying in the dark, that realization can soften rather than sharpen your thoughts. The idea that Planet 9 might still be waiting in the background while 3 Atlas crosses the foreground once turns the sky into a layered stage. On one layer, familiar constellations hold their shapes as they have for generations. On another, unseen masses and fleeting travellers like 3 Atlas write a slower script that humans are only beginning to read. As the narrative continues, attention will shift from these hidden architectures of rock and ice to the even larger frameworks of space and time, where 3 Atlas becomes a small probe crossing the edges of our current physics. When physicists speak of quantum gravity, the discussion usually unfolds in equations and thought experiments rather than in the path of a real object. Into that abstract landscape 3 Atlas enters as a quiet, moving test mass, crossing distances where the smooth picture of space might begin to fray. Some theories suggest that on the smallest scales, space-time is not perfectly continuous, but grainy like a fabric woven from tiny threads. Under that hypothesis, every long journey through this fabric leaves a trace, and the long hyperbolic arc of 3I Atlas becomes an almost poetic example. Over millions or billions of kilometers, the motion of 3I Atlas could in principle accumulate minuscule phase shifts or structural stresses that ordinary models never consider. In this view, any subtle mismatch in the orbit or spin of Atlas might whisper about the texture of the medium it has crossed, rather than about the object alone. No one claims to have seen such a signature in 3I Atlas, and current measurements are far from the precision required. For now, Atlas remains a speculative probe, more useful as a story that stretches imagination than as a confirmed experiment. Even so, the idea that 3I Atlas might carry scars from the fine structure of space-time itself changes the way some researchers look at the visitor. Atlas becomes not only a piece of interstellar ice and rock, but a kind of seismograph for the deep grain of reality recording vibrations we cannot yet read. For you listening in the dark, this perspective softens into a feeling rather than a calculation. 3 Atlas can be imagined as a small traveller passing over barely perceptible ripples, like a boat gliding across a very calm, very ancient sea. The notion that those ripples might exist at all reminds us how incomplete our picture remains even after tracing the path of 3 Atlas so carefully. In the next stretch of the journey, attention will turn from the granular fabric under Atlas to the even larger forces that shape cosmic expansion, and to how uncertainty at those scales echoes the uncertainties wrapped around this single passing guest. On the larger scales, far beyond the path of 3 Atlas, cosmologists study a different kind of mystery. They look not at single objects, but at the way space itself seems to stretch, as if the fabric holding 3 Atlas and every galaxy was slowly being drawn outward. To describe that stretching, they use the term dark energy, a placeholder for a pressure that makes the universe expand faster over time. In the simplest picture, this energy is perfectly uniform, a constant background against which 3 Atlas makes its brief passage. Some theoretical work, however, asks a quieter, unsettling question. What if that background is not completely constant? What if the effective temperature of dark energy, the tiny fluctuations in its strength, can vary slightly from place to place, or moment to moment, changing the stage on which 3 Atlas moves? Hints for such ideas sometimes arise in studies of the cosmic microwave background, the faint afterglow of the early universe. Maps of that glow show small patches that are a little cooler or warmer than average, and a few researchers wonder whether more subtle variations might whisper about evolving dark energy rather than simple primordial noise. If that were true, then the entire framework used to describe the journey of 3 Atlas would be resting on a floor that is itself not entirely stable. There is no consensus on this possibility, and most data still fit comfortably within the constant dark energy model. For now, 3 Atlas travels through a cosmos that in practice behaves as if the rules are smooth and steady. Yet the mere existence of these alternative views has an echo. They remind us that the uncertainties surrounding 3 Atlas are part of a much wider pattern of not knowing. The same humility that keeps scientists from overstating what Atlas means also guides them when they talk about the ultimate fate of the universe. As you listen, 3 Atlas becomes a small marker of scale. The visitor drifts through a night shaped by forces we barely grasp, while minds below try to trace both the path of Atlas and the shifting outlines of the very space that carries it. In the final turn of this narrative, attention will fold back toward you and the sky overhead to consider what it means to rest comfortably inside so much unresolved beauty.